All right, let's dive straight into this explainer and decode the hidden dangers of rapid software deployment. Think about it for a second. Imagine a high-speed, automated assembly line just constantly churning out the apps, the banking tools, and the operating systems that we literally rely on every single day. Now imagine that very same automated engine secretly slipping hidden vulnerabilities right into the final product. It's this massive balancing act, between breakneck speed and absolute critical safety. So today, we're going to unpack exactly how to secure it. And we really have to begin with this terrifying reality from the Ponemon State of Cybersecurity report. 66% of organizations were attacked in the last 12 months alone. But here is the truly crazy part. Nearly half of those victims directly blame insufficient security measures within their own software delivery pipelines. Basically, the very automated engines driving our software speed are leaving the front door wide open. So here is our roadmap to rebuild our security architecture. We're covering 1, the high-speed vulnerability, 2, the shift-left mindset, 3, 6 steps to security, 4, safe data testing, and finally, 5, the future of security. Let's kick things off with Section 1, the high-speed vulnerability and the illusion of speed. Okay, so the crucial point here is that while CI/CD, continuous integration and continuous deployment, accelerates development immensely, allowing developers to release code 83% faster, that exact speed makes it an incredibly attractive target. This level of automation is an undeniable efficiency boost, for sure. But without integrated security, it's literally like upgrading to a high-speed bullet train, but completely forgetting to install the brakes. Because of this centralized automation, hackers have realized the pipeline is essentially a skeleton key. I mean, why attack a single deployed app for a one-to-one return when you can just compromise the supply chain and infiltrate every single piece of software that pipeline produces? This realization has led to a staggering 430% surge in next-generation supply chain attacks. And these infiltrations, they're incredibly stealthy. According to IBM, it takes a business an average of 197 days just to discover that a data breach has even occurred within these complex systems. Just think about that. That's over 6 months of an attacker quietly sitting inside your infrastructure, just watching how you operate. And once you actually find it, it takes an additional 69 days just to tackle the issue and patch the vulnerability. When you step back and look at those numbers together, you're looking at nearly a year of absolute chaos stemming from just a single pipeline vulnerability. For the perfect storm of these vulnerabilities, we really have to look at the 2020 SolarWinds catastrophe. Attackers designed custom malware specifically to observe the build cycle. Then, they seamlessly slipped their malicious code right into official software updates, which caused massive data breaches across thousands of organizations, including major U.S. government agencies. But you want to know the most mind-blowing detail? The whole shebang was initiated by a poorly selected password, probably something like password123, that was exposed by an intern on a public server. The devastating SolarWinds breach proves that human error is just inevitable, which makes automated safety nets absolutely mandatory. Which brings us to Section 2, the shift-left mindset, moving security to the front door. Enter DevSecOps. This is a philosophy that stops treating security as an isolated step at the finish line. We call this the shift-left approach. Imagine a software development timeline moving from left to right. Shifting left means integrating security checks at the very first code commit, on the far left, and then at every single subsequent stage, so you're building security directly into the core of the application. The contrast here is stark. The old way isolated security way over at the far right, just a tedious final check right before lunch. But the new way integrates it everywhere. It's kind of like, instead of checking the locks as you leave the house, you systematically verify everyone before they even enter the building. If SolarWinds had used an automated secret scanner at the front door to reject that intern's exposed password, that entire global disaster could have been prevented. Moving on to Section 3, 6 steps to security. We're fortifying the assembly line. To achieve this hardened CI/CD pipeline, there are 6 highly actionable steps, ranging from fixing initial misconfigurations all the way down to automating data security. Let's break down the most vital mechanisms. First up, we've got to harden the foundation. Did you know a terrifying 63% of third-party code templates contain insecure configurations right off the shelf? That means you could be importing vulnerabilities before writing a single line of your own code. To combat this, you have to strictly enforce least privileged access controls. Basically, only essential personnel can alter critical infrastructure. On top of that, use pull requests as quarantine zones. Set up automated scanning mechanisms that automatically reject high-entropy secrets and exposed passwords. With so many third-party templates harboring flaws, limiting administrative access and rigorously scanning pull requests is your critical first line of defense. And I really love this quote because it brilliantly illustrates the concepts of infrastructure as code, or IAC, and policy as code. It's literally like having an automated bouncer at an exclusive club. In the past, human engineers manually configured servers and checked security rules, which leads to inevitable human error. Now, infrastructure and security policies are codified into executable text templates. The system hardwires the VIP list and the dress code directly into its programming. It enforces your baseline rules instantly, consistently, and without making manual exceptions. Now, for continuous testing, we have 3 distinct methodologies working together concurrently. You have SAST, which analyzes the source code from the inside. It's exactly like reading the architectural blueprint before pouring concrete. Then there's DAST, the dynamic black box method. This mimics a real-world attacker by violently shaking the front door from the outside to see how the running application reacts. Finally, penetration testing runs highly coordinated simulated cyber attacks to uncover hidden backdoors. The sheer genius of the CI/CD pipeline is that it orchestrates all these tests automatically in the background, so you find deep structural flaws without sacrificing that 83% speed boost we talked about earlier. All right, Section 4, Safe Data Testing, Protecting Privacy in the Pipeline. To run those dynamic tests effectively, developers need realistic data. But using live production data exposes sensitive, personally identifiable information, which completely violates data governance policies. So, what's the solution? Automating data security with these 3 strategies. Data masking changes actual sensitive values while keeping the formatting intact. Synthetic data uses an AI algorithm to generate entirely new characters from scratch. And service virtualization mechanically simulates the behavior of external APIs, like payment gateways, so your automated tests don't fail just because a third party goes offline. Together, these 3 strategies let developers run automated dynamic tests without ever exposing actual sensitive info. Now, you might be wondering, if synthetic data provides literally zero risk, why even bother with data masking? Well, the truth is, synthetic data can sometimes be a little too perfectly clean. Real-world databases have weird structural quirks, bizarre edge cases, and messy formatting anomalies. So, while synthetic data is great for zero risk, data masking is crucial because it accurately preserves the messy organic quirks of real data for realistic stress testing. It scrubs out the sensitive info but leaves the flaws intact, so developers know their code will actually survive contact with reality. And finally, Section 5, the future of security, watching the watchers. Look, the reality is that the cyber threat landscape just never stops evolving. You can't just build this pipeline and walk away. Robust, continuous monitoring and auditing are absolutely mandatory. You need dedicated DevSecOps tools to persistently flag exposed secrets in any new code. Furthermore, those open source libraries that developers import to save time, they require constant tabs to prevent sudden supply chain infiltrations. Even with a flawless assembly line, continuous monitoring is the only way to maintain visibility and catch newly imported vulnerabilities over time. So I want to leave you with this final, provocative thought to consider regarding the future role of human intuition in our automated pipelines. As AI gets exponentially better at generating data and increasingly begins writing software code itself, will humans become the only real vulnerability left? Or conversely, as automated systems become completely ubiquitous, will human intuition be the absolute only thing capable of catching the incredibly complex flaws generated by AI? It's a fascinating dynamic, isn't it? The machine protecting us from the machine. Keep questioning the technology you rely on every day. And thank you so much for joining me for this explainer.